Okay, so it's day 1.5, section 1.5, day 2. We're talking about our non-rigid transformations. That would be our vertical stretches and compressions and our horizontal stretches and compressions. So the key thing to remember here is that a vertical stretch up here, this looks the same as a horizontal compression, and a vertical compression looks the same as a horizontal stretch. So let's look at it in action. So this guy here, my parent function would be x cubed. So that's the cubic function. First, I'm going to draw you my parent function. It looks like an S. And then my transformed function, I've got one transformation. It's this 1/4. That's outside of my parentheses. So it's going to be a vertical compression by 1/4. In other words, I'm going to take all of my y values, which in this case, this is my table. Those were the 3 points I have for my cubic. And I'm going to compress all of those y values by 1/4. So divide them by 4. This would become negative 1/4. 0 divided by 4 is 0. 1 divided by 4 is 1/4. Now we don't care about our old y values. These are my new points. I've got a point at negative 1, negative 1/4, 0, 0, and 1 positive 1/4. So it compresses it vertically and it gives us a fatter looking cubic function there. All right, for B, now my parent function is x squared. Put my parent function back in red like we had before. It's our parabola, right? And it looks something like this. I can rewrite this 0.2. I know that can be written as a fraction as 1/5. So since we're in the parentheses, I'm going to call that a horizontal stretch. Remember, it does the opposite. It says to divide by 5. We're going to do the opposite. We're going to multiply all of our x's by 5. So for my parent function for quadratic, when x is negative 1, y is 1, 0, 0, 1, 1. So that's this point, and this point. Again, for our x's here, we're going to multiply them by 5 for my horizontal stretch. So 5 times negative 1 would be negative 5. 5 times 0 is 0. 5 times 1 is 5. Now we don't care about these x's anymore. But I still have this negative sign out there. It's outside of the parentheses, so it's going to mess with my y's. It's going to make all my y's negative. So negative times 1 is negative 1. Negative times 0 is 0. Negative times 1 is negative 1. Now we don't care about these y's. So these are my transformed points. I've got a point at negative 5, negative 1, 0, 0, and 5, negative 1. So we flipped our parabola upside down. And we did a horizontal stretch, which also looks like a vertical compression. So a big fat parabola that's turned upside down. All right, let's look at the U-tries from today. So this first one is 4a. We're going to graph our parent function first. That's our greatest integer function. Don't confuse it with an absolute value where there's just one bar. The difference between absolute value and greatest integer has these little feet, and it's hard to tell on here, but there's 2 lines on each side, not just one. All right, and this is what our greatest integer function looks like. So remember, we call this also the step function, because it makes little stairs, like a staircase. So a little tedious to do, but there it is. And then if we look at our transformation, I've got one transformation happening. It's outside of my quote-unquote parentheses. It's not inside those little bracket symbols. So that means it's a vertical transformation, and it says -4, which means we're going to take our function and we're going to shift it down 4. This is a vertical shift down 4. So I'm going to take this piece here and shift it down 1, 2, 3, 4. And then that's my starting piece. I'm just going to shift everything down 4, which means my staircases start there and we just start making them again. Again, a little tedious. All we have to remember is it's a closed circle on the left side, open circle on the right side. We forgot what greatest integer function means. Remember, it's the greatest integer that is less than or equal to our point. It's kind of like we round everything down. Even 1.7 would become 1, not 2. So there we go. There's our greatest integer function shifted down vertically by 4. For 4b, my parent function is a rational function. Anytime x is in the denominator, we've got a fraction going on. That's a rational function. If I have stuff happening in the denominator, that's kind of like happening in the parentheses. So this is where I would find all of my horizontal shifting, but if you notice on this one, nothing's shifting horizontally. We do have a vertical shift with this +3. That's a vertical shift up 3. This 15 here is actually a vertical stretch. This is 15 times 1 over x. That's the parent function. So 15 times 1 over x gives me that 15x that you see here. So that's why it's a vertical stretch by 5. Vertical stretch by 15. This guy here is my vertical shift up 3. So first, let's graph our parent function. Remember, we have an asymptote on our x-axis. There's our horizontal asymptote. And my vertical asymptote is on the y-axis. The parent function goes through this point and this point. -1, -1, +1, +1. Kind of hugs those asymptotes, especially as we get towards 0. So that's the parent function. I said this guy got shifted up 3. So this horizontal asymptote, it also gets shifted up 3. So it's going to be right here. You've asked me in class, do we have to put the parent function on there? Absolutely not. Especially, I think, for rationals, it gets kind of confusing. So I'm going to go ahead and erase the red one. So the red one is my parent function. That's what we're trying to move around. Maybe I'll get rid of it. Okay. So then I'm getting rid of that horizontal asymptote because we moved it up. There we go. Like I said before, we have nothing happening in the denominator, so I don't have a vertical or I don't have a horizontal shift left or right. The vertical shift shifts the horizontal axis up. If I had a horizontal shift, it would move this guy left or right, but I don't have one, which means my vertical asymptote is going to stay on the y-axis. And then normally, the parent function, like I said, would go through this point and this point. But what that 15 does is it stretches it further away from those points. So as long as you give me a good graph that looks like it's going to negative or get close to those asymptotes, and it doesn't go through the parent function points, which are these red dots, then I can tell that you've told me it's going to be a stretch there. So that's what 4b looks like. And then I'm going to make one more video, and that's going to be graphing the piecewise functions.
Bye guys, and don't forget to subscribe.